Now question number 8, exercise 4.5. Question number 8, find the inverse of each of the following matrices. Find the inverse of the following matrix. Here we will find the inverse by that finding adjoint, determinant, value of determinant, etc. So the question number 8 is, the matrix is given 1 3 5, 0 3 2, 0 0 minus 1. Now first of all we'll go for finding the cofactors. So we start with the position a11 minus 1 to the power 2, and then leaving this way 3 0 2 minus 1, which is equal to this plus and minus 3, and then minus 0, which is equal to minus 3. a12 which is equal to minus 1 to the power 3, and 1 2 is this one, this way, leaving 3 0 5 minus 1, which is equal to minus 3 minus 0, which is equal to plus 3, and the a13 which is equal to minus 1 to the power 4, and this position is 1 3, and leaving this way, so 3 3 5 2, which is equal to 3 2 is 6 minus 15, which is equal to minus 9. Now the next 3 and then the remaining 3, first row is completed. Second row a21 which is equal to this 3 minus 1 to the power 3 and determinant, leaving this way 0 0 and 2 minus 1, which is equal to minus 0 minus 0, which is equal to 0. a22 which is equal to minus 1 to the power 4, 2 2 means this 3, so leaving this way 1 0 5 minus 1, 1 0 5 minus 1, this minus 1 to the power 4 positive, and minus 1 minus 0, which is equal to minus 1, and a23 equal to minus 1 to the power 5, and this a23, so leaving this way 1 0 5 2, 1 0 5 2 equal to minus 1 to the power 5, this thing negative, and then 2 and then minus 0, which is equal to minus 2. Now we'll go for row 3, that is this. So first cofactor of row 3 is a31. In a31, this one, this way we are leaving, so is equal to minus 1 to the power 4, and subdeterminant this way leaving 0 0 and 3 0, so overall 0 and 0 and into this thing, so 0. a32 which is equal to minus 1 to the power 5, and subdeterminant is, this is a23, so leaving this way 1 0 and 3 0, 1 0 and 3 0, so 1 0 3 0, this will be equal to minus times 0 minus 0, 0 is equal to 0, and the last one is a33 which is equal to minus 1 to the power 6, and subdeterminant this minus 1 we are talking about, so 1 0 3 3, 1 0 and 3 3, which is equal to minus 1 to the power 6 plus 1 and 3 into 1 3. So now this we have taken up to this. Now adjoint of this matrix A, adjoint of matrix A is equal to in the same order. That means first of all 1 1 minus 3, and then this 1 1, then 1 2 is plus 3, and then 1 3 is minus 9. Then second row 2 1 is 0, then 2 2 is minus 1, and 2 3 is minus 2, and the last row is 3 1 is 0, 3 2 is also 0, and this is 3. So it's transpose, that is called adjoint of A, which is equal to, we will change the order. So minus 3 plus 3 minus 9, 0 minus 1 minus 2, and 0 0 3. This is called adjoint of matrix A. Now few days back we had studied this A inverse, the formula I told you, that is 1 upon determinant of the matrix into adjoint of the same matrix. So we'll put here, first of all we'll find this determinant. A is equal to 1 3 5 0 3 2 0 0 minus 1. We'll expand it through R1. So R1 is, which is equal to 1 into minus 3 and minus 0, which is equal to minus 3. And then putting all these values in A inverse, we will have A inverse of this matrix is equal to this 1 upon this determinant, that is minus 3, and then adjoint of this matrix, which is equal to this adjoint of A is minus 3 plus 3 minus 9, 0 minus 1 minus 2, and 0 0 3. This is adjoint. So now dividing by minus 3, we will get this minus 1 and this plus 1 actually here, and then here dividing by this thing, so minus 1, and then dividing by 3, so 3, and then 0, and then plus 1 upon 3, and then here we will have 2 upon 3. This 0 is as it is, the next is also 0, and the last one is minus 1. So this is A inverse of this matrix A. Question number 13. Matrix A (3 minus 1 1 2). Then show that A square minus 5A plus 7 into identity matrix equals to 0. Hence find A inverse. So what we are going to do, this by putting the value of matrix A into this, we have to find out this matrix inverse of this matrix. So this question is a little tricky in the sense, what we are going to do, first of all this 7i is equal to let us give it number 1, and then 7i is equal to minus a square plus 5a. Then let us take a common out of this, so inside minus a plus 5, and this is 7i identity matrix. Then multiplying both sides by A inverse to this statement. So what do we get? 7i into A inverse is equal to A inverse into A times minus A plus 5. What does it mean? 7i A times 7A inverse is equal to this 2 gives value 1, and then minus A times addition of 5. Then A inverse of this matrix is nothing but 1 upon 7 times minus A plus 5. This is actually what we wanted in this question. So what we are going to do, so we will put the value of A over here and then adding with the 5. That how we will add, that I tell you, and then dividing this matrix by 7 will get the desired result. So this cancel A inverse, so here we will have identity matrix. So here we will have identity matrix I. So now we'll put the value of A into this. So A inverse is equal to 1 upon 7 times minus times matrix A, which is 3 minus 1 1 2 and plus 5 times identity matrix, so 1 0 0 1. So this is identity matrix. So now we will put 1 upon 7, so then minus 3 and then plus 5 and then minus 1 and then 0 and then plus 1 plus 0 and then minus 2 and then plus 5, which is equal to 1 upon 7 plus 2 minus 1 1 plus 3, which is nothing but dividing each element by 7, that is A inverse, which is equal to 2 by 7 minus 1 by 7, 1 by 7 and 3 by 7 is the inverse of this matrix A. So this is a little tricky and a shortcut method of finding A inverse when such equations are given. Question number 14. For matrix A 3 2 1 1, find the numbers A and B such that A square plus A times A plus B time identity matrix is equal to 0 matrix. Hence, find A inverse. So that means this question is for A inverse. It is similar to this question number 13, but here we need to find out the value of these two constants. So for this, what we are going to do, we will put the value of A square, A and I into this. So A square means matrix A times matrix A. So 3 2 1 1 into 3 2 1 1, multiplication of matrices, 2 by 2 2 by 2. So the last order of the resultant matrix will also be 2 by 2. So this row 1, then column 1 and then row 1 column 2. Similarly this for this. So 3 3s are 9 plus 2, 3 2s are 6 plus 2, then column 2 1 2 and then row 1 with this 1 into 3 3 plus 1 and 2 plus 1, which is equal to 11 4 8 3. This is A square. Now we'll give this number 1. So from 1, A square means this matrix 11 4 8 3. We'll put all the terms here plus small a times matrix A. Matrix A means 3 2 1 1 plus B times identity matrix of 2 by 2. So 1 0 0 1 is equal to 0 matrix of order 2 by 2. Now this should be multiplying all this inside. So 11 plus 3a plus b, then 8 plus 2a plus 0, 4 plus a plus 0, and 3 plus a plus b into 1b is equal to 0, 0, 0, 0. Now this, comparing both sides, 11 plus 3a plus b is equal to 0. So means 3a plus b is equal to minus 11, equation number 2. Also 2a plus 8, 2a plus 8 is also equal to 0, implies a is equal to minus 4. A got already minus 4, and from this last we will get a plus b is equal to minus 3. So from here a already we got minus 4, so minus 4 from here, this will go that side, so b will be equal to plus 1. So we got b is this one, a is equal to this one. Now for a inverse, from 1, a square, value of a is minus 4, so minus 4 times a plus b is 1, so it is already identity matrix is equal to 0. A square minus 4a plus I, identity matrix is equal to 0. B is equal to 1 and a is equal to minus 4. So now identity matrix is equal to minus a square plus 4a. Taking a common, minus a, and then we have plus 4, identity matrix. Now before finding inverse of any matrix, you need to check one thing, and that is its determinant should not be equal to 0. Then only you can have this A inverse, otherwise its value will be undefined. So in this case we have determinant of A is 3 minus 2 is equal to 1, which is not equal to 0. So that means A inverse is possible in this case. So now multiplying both sides by A inverse to this statement, we will get A inverse into identity matrix A inverse is equal to A inverse into A identity matrix, and then minus time matrix A, which is equal to 3, 2, 1, 1, and plus 4. So plus 4 means 4 times identity matrix 1, 0, 0, 1, which is nothing but minus 3, and then plus 4, minus 2, and then plus 0, and then minus 1, plus 0, and minus 1, plus 4, which is nothing but plus 1, minus 1, minus 2, plus 3. This is A inverse. Question number 17 is MCQ type, that let A be a non-singular. First of all, you need to understand the meaning of non-singular matrix. Any matrix is said to be non-singular if its value of determinant is not equal to 0, and this is the condition we learnt while finding the inverse of matrix, that this is the condition where we can find the inverse of matrix if any matrix is non-singular, means the value of its determinant is not equal to 0. This is non-singular. If now this question number 17 is what? This is the meaning of only non-singular. This is not question number 17. Now the question is, it is a non-singular square matrix of order 3 by 3, question number 17. Then determinant of adjoint of matrix A is equal to option A, simple value of determinant of matrix A, option B, square of its determinant's value, C, cube of this, and D, 3 times of its determinant. So to get the right option, you need to learn one thing, that is basically formula, that adjoint of matrix A and then its determinant is equal to simply the determinant of that matrix power order minus 1. What is this order minus 1? Means if it is a square matrix of 2 by 2, then 2 minus 1. If it is a square matrix of order 3 by 3, then 3 minus 1. If it is a square matrix of order 4 by 4, then we will put here 4 minus 1. Now come back to this particular question. So it says that its order is 3 by 3. So now obviously here in this question we have this order is 3. So in this question particularly, its value will be determinant A and power is 3 minus 1, which is equal to determinants A power 2. So that means the option B is the right answer. Next and last question of this exercise, that is 4.5, question number 18. If A is a invertible matrix. Now what is invertible matrix? Invertible matrix means its inverse exists. That means if we multiply this matrix with its inverse, it will be the identity matrix. Invertible matrix of order 2, then determinant of its inverse is equal to what? The option A is simple its determinant, option B is 1 upon determinant of its matrix, option C is 1, and option D is 0. We need to check. Now A is a invertible matrix of order 2. Then we have to find out the value of this. Okay, so as you know that determinant of multiplication of two matrices can be written as determinant of A into determinant of B. This you remember. Then in this particular question, A is said to be invertible matrix, means since A is invertible matrix. Therefore A into A inverse is equal to identity matrix. Taking determinant of both the sides, so determinants of A into A inverse is equal to determinant of identity matrix, which is equal to 1. And this rule can be applied here. So determinant of A into determinant of A inverse is equal to 1, implies determinant of A inverse is equal to 1 upon determinant of A. So the option B is the right option, that determinant of inverse of matrix A is equal to 1 upon determinant of A.